More definitions. This time we're asking about latent heat. Latent heat. You know, this term is so important. We hear about it all the time in HVAC, and usually we're hearing it in the sense that it's a term which is different than sensible heat, right? There's sensible heat of a substance, latent heat of a substance. And we want to be very clear on understanding the differences between these two terms. So what I'm going to do is I'm going to tell you what the latent heat of a substance is by giving you the answer. The answer is A, okay? That latent heat is the heat required to change the state of a substance without changing its temperature. That's very interesting, right? It's very interesting. So what does that mean? The best way to explain this really is to go through an exercise talking about 1 pound of ice. 1 pound of ice. And we're going to keep adding heat energy to the ice, and we're going to get it to increase in temperature and change state. We know that if we take ice and keep heating it and heating it and heating it, eventually we'll have steam, right? I think we can all intuitively figure that out. But what are we doing specifically? What kind of heat are we adding to the ice as we move from ice to steam? Are we adding sensible heat? Are we adding latent heat? Are we adding both? So we're going to explore that a little bit in greater detail right now. So what I've done here is expanded the image in your question, and the image is a graph. And in this graph, you can see we have a vertical axis and a horizontal axis. I'm sure most of you have seen this graph before. And the vertical axis, we have temperature in degrees Fahrenheit right here, okay? And so we're going to start down here at 0, and we're going to move our way all the way up to somewhere above 250 degrees Fahrenheit. Don't worry about the degrees Celsius. We're just going to talk degrees Fahrenheit. So we have increasing temperature on your vertical axis. And then on our horizontal axis, what do we have? Heat content, right? So we're adding heat from left to right in terms of BTUs to a substance. In our case, we're going to talk about 1 pound of ice. 1 pound of ice, okay? So let's clear this up a little bit. And we're going to start right here in the bottom left-hand corner at point number 1. You see how this is identified as step 1? I like that. So what do we have at step 1? We have 1 pound of ice. And what do we know about the ice? The ice is currently at a temperature of 0 degrees Fahrenheit. Okay? Now, if you take a block of ice at 0 degrees Fahrenheit, first thing you should think is I'm way below its freezing point, because you should know by now the freezing point of ice is 32 degrees Fahrenheit. So we've actually really super cooled it, if you will, right? We removed so much heat from it that we're all the way down to 0 degrees Fahrenheit. Now, if you start adding heat energy to the ice, what you're doing is increasing its heat content in terms of BTUs. So I'm going to take my 1 pound of ice, I'm going to move from left to right on the horizontal scale. And you have to imagine in your mind that we're continually adding more and more and more BTUs to the ice. What's going to happen? Well, the first thing that's going to happen is our 1 pound of ice is going to move from step 1 to step 2, from here to here. We're going to have to add BTUs of heat energy to raise the temperature of the ice from 0 to 32 degrees Fahrenheit. Each time we add a half a BTU, actually, we're going to increase ice by the temperature of 1 degree Fahrenheit, because the specific heat of ice is 0.5 BTUs per pound. So we're going to add heat energy to the ice. Why is this important right now? Because if you're adding heat energy to the ice and its temperature is increasing, then technically from 1 to 2, you're adding sensible heat, right? That's all you got to know for now. You're adding sensible heat energy. You're adding an amount of BTUs to a substance which causes its temperature to increase. So you must have added BTUs in the form of sensible heat energy. Now, when ice, 1 pound of it, gets to step 2 in the drawing, it will reach 32 degrees Fahrenheit. That represents the freezing point of water, okay? So if we can warm it to 32 degrees Fahrenheit, The moment it hits 32, yet you continually add from step 2 to 3 more heat energy to it, because you're at 32 degrees Fahrenheit, it will no longer increase in temperature. It will just hold at 32 degrees Fahrenheit. What will change, though, is its state. You'll start melting the ice. So from 2 to 3, we're melting ice. I'm just going to write here, melting. And when you're melting ice, you're still adding heat energy to it. But from 2 to 3, you're adding latent heat. Latent heat energy added to the ice. And of course, according to our question, the correct answer A, you're adding an amount of heat energy to a substance which causes it to change state. In this case, we're changing the state from a solid to a liquid. You know, we could be changing state from liquid back to a solid by removing latent heat energy from it and freezing water back to ice. But in this case, we're moving from left to right. So you can add latent heat energy to a substance, or you can take latent heat energy away. As long as state is being changed, it's a form of change in latent heat energy in that substance. Now, eventually, all of the solid ice will melt and turn to liquid. You'll go from 100% solid to 100% liquid. It just so happens that to take 1 pound of ice and melt it to 1 pound of water, you need to remove 144 BTUs of latent heat energy from it. But for the purposes of our question, I just want to talk about changing state, okay? So if we change all of the ice into liquid water, that means we would have removed latent heat energy from it. Now, if we continually add more heat energy to this now fully stated water, we're going to move from stage 3 to 4 here. Stage 3 to 4 up the temperature scale, because there's no more ice to change state into a liquid. But we're going to keep adding heat energy, moving left to right to that liquid, which means we're warming it. Which means from 3 to 4, if we are actually adding heat energy, we're adding sensible heat once again. All right. Now, to keep things simple, if we eventually warm that water up all the way to 212 degrees right here at step 4, we would have added a lot of sensible heat energy to that water. And in fact, we would have added 180 BTUs of sensible heat energy to it. But the point is, once you've warmed the water up to 212, if you continually add heat from step 4 to step 5, you will change its state, because now you're at the boiling point, right? So we start boiling the water. So once again, step 4 to 5, you see the difference. Step 4 to 5, you're adding latent heat again. Why? Because it's changing state. Now, eventually, you'll run out of liquid to boil. All of the liquid water will turn into vapor, right? It's like a boiling pot of water. The vapor leaves the pot. There's no more liquid to boil. But that vapor can still be heated. In fact, you can superheat it. It's the definition of superheat. Adding a certain amount of sensible heat energy to a gas that causes an increase in its temperature. We look for superheat at the outlet of evaporators, don't we? It's just that we're talking about refrigerant and not water. So if you take steam at 212 and add more heat energy to it to get its temperature to go to 220, 230, 240, 250 degrees Fahrenheit, you're superheating it by adding more sensible heat. So that's why step 5 and onward would be, of course, adding more sensible heat. So without even putting all the numbers in, which we do want to commit to memory because they're so important about water, for now it's important to understand that if we take ice, warm it up to 32 degrees Fahrenheit, we add sensible heat to it. Then we melt the ice at 32 until it's all liquid. We add latent heat to it. And then we take that water and we increase its temperature to the boiling point. We add sensible heat to it. And once it's at its boiling point, we add more heat to it, change it to steam. That's latent heat energy being added to it. And once it's all steam, any additional BTUs that it receives to take it above its boiling point would be, once again, sensible heat. So sensible, latent, sensible, latent, sensible. Try to clear that up in your minds, and you're going to be flying on the Sea of Q.